Today's episode is sponsored by Huber Engineered Woods, the makers of Advantech Subfloor. My firm, Aero Building, has been using exclusively Advantech Subfloor on all of our remodels and new builds since the late 90s. I can't think of another product besides like 2x4s and 2x6s that we were using in the late 90s that we still use now, that we still rely on, that we still think is the best possible thing to do that job. And that means something. I mean, that really means that we're relying on the engineering behind the product, the process for them putting it together. Everything that they do to make a quality product guarantees that we can make a product. And now that we use their subfloor adhesive and screw the panels in place, I don't feel like I've ever built a better floor assembly. Anything stronger, anything more rigid, anything that I felt like I could put my name on any better than with their product. So check out their Bringing Your A Game campaign on their new website, huberwood.com. Thank you, Huber Engineered Woods. Today's episode is also sponsored by Aero Barrier. This is a unique product that you kind of have to see to believe. It's a great addition to your air barrier that also comes with guaranteed results. The process of installation gives the site crew real-time results so that those performance benchmarks for air leakage can be easily met. They're pressurizing a building, aerosolizing a sealant. That sealant finds those cracks for you and seals them. And because they're using basically a blower door to measure the air moving through the building, those real-time results are simple. You can give them a performance benchmark and they can say, okay, we'll tell you when we get to that point. New construction or even existing homes can benefit from less air leakage, and Aero Barrier can help. I've used the product on 2 homes now, and we're able to make those air leakage numbers be like 1/10 of what's allowable by passive house standards, and that's a pretty amazing thing. That means we're chasing like half a business card worth of total opening on a 9,000 square foot envelope. Those are holes that we weren't able to find without Aero Barrier. You don't have to be the world's most high-performance builder to see value in this product. I think that this product is going to be something that we see in every home. Anybody who's really trying to meet those air leakage standards that are met forth in the code, this can be a great addition to your air barrier. And I think when you partner it with other good quality building practices, this thing is simple and it's a no-brainer. Check them out and find your local installer at aeroseal.com. I just wanted to say, Aero Barrier, thanks for your sponsorship today.
Welcome back, everybody, to the Unbuild It podcast. This is Pete Yost, and I'm joined by my amigos, Steve Basic and Jake.
What's up, everybody?
Hello, hello.
Yeah. So this week, it is Unbuild It podcast goes underground. This is not subversive. This is submersive. Huh? What do you think, guys?
Wow. Did you write that in advance?
I think Jake should do the
on the
intros
fly
from now on.
The look on Steve's face was absolutely priceless. So when the Unbuild It podcast goes underground, we're basically talking about foundations of all types, but it's what happens below grade. And I guarantee you right now that this Unbuild It podcast is going to be well below grade.
It's 2 in one intro. That's surprising.
Oh. I actually had a pain.
Well,
I
if
had
you're
heart
still
pain on
with
that.
us.
I actually had heart pain on that.
No, so we're talking
pauses.
about all kinds of foundations, right? But everything is below grade. Jake, can I start off with a little bit of a building science background?
I would love that, Peter. Thank you.
So, the thing to me that's interesting about being below grade is we got sort of 3 threats that are all bulk water. And we got the water that comes down on the building, and that's the building load we have to manage. Then we got the load that comes down on our lot or our property around it, and we got to manage or direct that. And then I think the scariest thing is if we have a water table, then we got to manage that load. So that we got 2 coming down from above, and then we got 1 coming up from below.
Dun, dun, dun.
So it's tricky. Steve, I think you agree with me that water table load is one that is kind of worrisome.
Well, it's worrisome because that one doesn't go away.
Exactly.
Right? I mean, you dig a hole and there's water 5 feet down. Guess what? Next year you dig a hole, there's water 5 feet down. Guess what? Dig a hole in 10 years, go 5 feet down. Guess what? You see water. It's a problem that just doesn't go away because you choose to put a foundation in the ground there.
So one of the things we're talking about, if you're digging a full basement, is do I have to build a boat hull?
Story.
Oh, you weren't done yet?
No, I wasn't done. I found that pretty offensive.
Oh man, I did not mean to go below the belt when we're going below grade.
Oh God, they are awful. No, I was just going to say, I actually had a client that came to me, wanted to build a new house, and I'll quiz both of you. He came to me, and he had already bought the property. Guess where the water table was on the property he bought?
I'm going to say, since you're asking us, like 18 inches, like something ridiculous.
No, it was
like
a little
that.
bit more than that. It was minus 30 inches.
Wow.
But it was like sustained water at minus 30 inches.
Yeah.
And of
did
course,
we get a in-ground foundation, or did you just pour a slab on top?
so you're going to love the design solution. So we
Piers?
knew we had to put this huge septic system in and had to do a bunch of things. So we actually pulled the foundation about 6 feet out of the ground. So what's cool is when you see the very early construction photos, literally 80% of the foundation wall is above grade. You know, the bottom of the footing is, or the top of the footing is, you know, pretty darn close to being at grade. So
Funny.
If he's got
And
a
then
water table at minus 30 inches, how did he put in a septic system? Must have built it all up.
we built it all up.
Yeah.
We brought in dirt. His whole front yard was post manufactured to like an additional 5 or 6 feet.
Holy cow.
Yeah, I
Did
mean
you
it's
have to
cool.
get, like,
'cause
a
Talk about a
nautical-
landscaping budget.
well, we did a really nice series of terraces to get into the house with stone walls. So the front of the house is actually gorgeous, and you would never know it because you drive up, and the front door is literally maybe 35 inches above like the driveway. So there's a couple terraces, no handrails on any of that stuff. So it actually worked out really nice in retrospect. But it's this knowledge of, you know, we worry about things underground, but it's almost like you have to worry about these things before you even build the house or get the house. Like, you know, this is a guy that went out, spent a good dime on a piece of property and didn't realize that he had a turf covered swimming pool. How do you like
So-
that one?
Nice. Nice.
We can address it from the same way at the our Spring Valley project, which is my personal house that Steve designed. It's an infill lot. There used to be a house there. We actually used to do some remodeling and maintenance on the house that was there before, and her house was struck by lightning. It burned partially, and between the fire and the water from the fire department, the insurance company said, take it down, start over. It's more than 50% value. And so she had somebody come in and bulldoze the house down to the foundation, basically. And she went to the city for a building permit, and the city said, well, you're in a floodplain. Raise the house 18 inches, or we can't give you a permit. And there was some back and forth, and she ended up abandoning the project and having the foundation removed. And when we bought it, we knew that site condition water was going to be a major concern, and we did effectively the same thing without putting in a basement. We raised the elevation of the lot by 50 inches and then didn't put in a basement because we knew that we'd have to be dealing with water table, and water below grade can be a real pain in the rear.
Well, to me, what's fascinating is we just said the name of this was We Go Underground, but it's interesting that,
Yeah, we said the opposite.
well, if the threat's high enough, like stop digging a hole, right? If it keeps filling with water, right? Go up, don't go down. Yeah. So when we talk about the different foundation types, you know, there's what? 4 piers, slab, crawl, and full basement. Does that pretty much cover it?
Yes, but technically I consider crawls just short basements
Short
for the
basement.
record.
Yeah.
Fair enough.
He's got a point. He's got a point.
Fair enough.
I silenced them both.
Well,
Oh.
so I just have this image of how a crawl space would have to be for Steve Basic compared to me, right? Because we better give you a bit more room in your crawl space, right?
Peter, I want to say, was it New Mexico? I went down through, you're not going to believe this. It was probably a 20-inch square hole to
I don't believe it.
a crawl space. It might have been a 24-inch square hole into
Okay.
a crawl space that the bottom of joists were probably around 20 inches
Oh boy.
above grade. And there were a couple places where there were beams that were like
Oh man.
16 inches. And I went, like, I didn't go down from the hole. I went down in like 30, 40 feet from the hole.
Wow.
So yeah, I was deep into minor 49er over there.
But that was when you're doing electrical work. When you're
No, this was I was looking at something. There was an issue. This was out in New Mexico. We did very few crawl space projects, but this was one of them. And
You know what's interesting is I think Bill Rose has done some work on sort of the evolution of crawl spaces. And I want to say it's not that they were just shortened basements, but originally it was skirting around piers. So the
Raised
crawl
pier
space wasn't actually
foundations.
below grade. It was a conversion to a space that was not an evolution of a full basement to a short basement. It was skirted, and now that created a very confused sort of pier constrained space that led us to start with crawl spaces. So that's another issue. Are we talking about that crawl space being confined pier space, or is it really truly underground?
I think for today's argument, let's consider it to be mostly below grade.
And Jay, another thing about this is that like Nadav's house here in Brattleboro, and I know Carl Seville from Atlanta has said there's a whole bunch of homes there where it's designed as a crawl space, but there is this like hallway that's full height just where the mechanical system is. And they call it a Dutch basement or a Dutch crawl. Have you ever heard this? Yeah.
Nope.
Because Steve has a really cool design for one of his projects where, he basically treats that space as strictly mechanical and limits the space of that to only what he needs for mechanical. Right, Steve?
That's actually one that Steve and I built together.
Yeah.
Yeah, we did.
Super cool project.
Yeah.
So
Peter,
you're primarily slab, right?
Yeah, it's a slab on grade, insulation on the top side of the slab and over top of the basement, and then 2 layers of subfloor so that we have a warm wood floor that we can then install hardwood flooring on, and we just have a corridor basement, basically.
So essentially, Steve, you built a mechanical chase underground.
Yeah.
Yeah, a
Design.
mechanical chase underground and what I would call the required basement, right? Because if you think about it, you're designing a 3,000 square foot house. The people might say, oh, I want to store some stuff in the basement. Well, they don't have 3,000 square foot of stuff they need stored. They might have 400 square feet of stuff that needs to get stored. So we built a basement that was adequate storage, but allowed us to put all the utilities and services in there. So you get kind of the best of both worlds. The top half of that hole is all the utilities. The bottom half of that hole is all storage. And it has a full code, approved stairway down to it. So you can walk down to it at any time, and it's all right there. You basically have a basement. You just have a much smaller one.
without spending $40K on a basement
Exactly.
that the clients who are aging in place aren't going to be accessing full time.
Yeah. You know, it's funny when I meet with clients and they say, oh, I want this, I want that. I need, a basement. And I tell them, I say, you don't need more space. You need less stuff.
Can we have a joint phone call with my wife this afternoon to talk about stuff?
Yeah, good luck. But hey, Peter, I just want to bring up one story because this one I still have bad dreams and nightmares about this. But years ago, Neil Moyer and I were in southern Mississippi doing evaluations on existing houses that were built on piers with metal skirts around them. And I remember vividly peeling back this metal skirt, shining a light underneath this 30-inch crawl space.
Oh, boy.
Everywhere I shine the light, the ground moved.
Oh, no. That is...
I looked at Neil and said, there's no way I am crawling in there.
You didn't just go, nose goes.
Yeah. Exactly.
Not it.
And
Well-
if this wasn't such a family show, I would tell you about the conversation with the homeowner.
So,
We had one
Anyways.
Go ahead, Jake.
one time that we opened up and I started to crawl inside of, and I put my hand on something and I kind of pulled my hand back a little bit. And then my project manager, I think it was AJ, was climbing in like next to me, and I just slid what my hand was on so that it slid underneath him, and he put his hand on it and just screamed, "Oh my God," and pulled his hand back, and he said, "Is that a raccoon?" And I was like, "Yes, I think it used to be a raccoon. I agree."
Oh, boy.
And I was just like, ugh, I think I'll wait outside. So let's not talk about that aspect. You figure out on your own how to keep those things from living down there. Let's talk about the building science aspect of that.
But that I might have a segue for that, which is these spaces have a reputation for being, inherently and unalterably damp, right?
Yep.
And that's because most of us grew up in homes where we were not thinking of those spaces as being truly inside the building, right? We dug a hole to try to keep the framing off of being, mixed with the ground. But these spaces had dirt floors. There was no real concrete. They were rubble foundations. So that's an inherent problem when we think that we can't manage that moisture that's below grade, because we can. We just have to meet the load with appropriate details.
Now, I could take that story, Peter, and tell you why little Stevie, me at a much younger age, loved laundry day with my mom.
Seriously.
Yeah. We used to, because the house I grew up in had a dirt
This is a
floor.
trick.
No, it's not a trick. This is 100% honesty. It had the house I grew up in. It had the stone rubble granite foundation.
So this is Adams, right?
And Adams, yep. And the basement was probably like 6.5 feet tall. As I grew older, I had to do a lot of ducking down there.
Mm-hmm.
But as a little kid, Mom would be like, hey, come on, I got to go down and do laundry. And our washing machine and dryer, there was a concrete pad in the corner and plumbing and stuff. And we would do it. But because it was a dirt floor, I had my trucks down there. So Mom would do laundry, and little Stevie got to play in his little dirt pile in the basement.
Huh.
And so when it was time for laundry, it meant that I got to play with my truck. So it was a good day.
Wow.
And radon.
Yeah.
And radon. Maybe that's my problem.
Steve goes nuclear.
So this conversation about it's about control. The same as half the building, 3/4 of the building science conversations that we have, right?
You know what, though, Jake? I'm going to back it up a little and say, before we get to understanding control, when you're talking about underground, you have to have knowledge before you can gain control, right?
What kind of knowledge?
Well, it's like that homeowner
Yeah,
that buys
yep.
a lot and has water 30 inches deep. But I'm going to give you another example. I did a project, a passive house, probably about 4 or 5 years ago. It's on the back side of a mountainside that's a ski resort.
Mm-hmm.
And it just so happened to be that's between Adams and where I live now. So it's on this highway that I drive normally. And it just so happens that I was going by it. I said, hey, let me swing by the site and take a look at some things. And it was pouring out. When I got to the site, I was absolutely amazed at how much water, surface runoff, was coming down the backside of that mountain.
Yeah.
And the job site where we put this house, keep in mind, it was about 400 feet long, the site. It was probably about 150 feet wide, but it dropped elevation almost 200 feet in the 400 feet.
Mm-hmm.
So it was basically a hillside. And when I say, like, at any point, you could just go across the ground and scoop up a handful of water. There was that much water coming down. So I think before we could talk about controlling, I think the first thing we need to understand is everybody needs to do their due diligence and really either have some kind of clause in your contract that prepares you for some unknowns that you would gain knowledge after you dig the hole. But it's one of those things where, as an architect, for example, if you're doing a site on a house, don't only go there on the sunny day. Go there when it's pouring rain and see what that site is doing, because your eyes, for whatever reason, I was very fortunate to think about swinging by that job site, because I would have never realized the magnitude of water that was moving across the surface of that. And it did change the design, because that leads into your control there, Jake, right? On this house that had a walkout on one side, but it had the side walls on the house were stepped, but the back wall was pretty much a dam.
Mm-hmm. Yeah.
Right? So the way I solved it was we had a perimeter drain tile down below, about 4 feet below grade. And for that 4 feet, we had a stone kind of gutter with a 6-inch perforated pipe that went around the house and bled to daylight left and right. So the idea was catch as much of that water that comes down off the hillside as surface water, drop it into that gutter, drop it into the pipe, and move it around the foundation. And that ground gutter wasn't up against the foundation.
Mm-hmm.
It was probably about 6 or 7 feet in front of it. And then at the foundation wall, we had waterproofing and a dimple mat with a perimeter drain at the base. But the idea, like you were saying, Jake, in control is we try to control the magnitude of most of the water, and then we dealt with whatever residual got by.
So you're kind of describing to me a eave gutter and a rain screen for my siding just pushed further down the site, right?
Yes, exactly.
When you talk about assessment like that, Steve, I wrote a blog for Green Building Advisor about water tables in basements, and it's hard to get good information about water tables. And what I finally decided is that the most important thing to do is, and Jake, you and I talked about this, go find the oldest excavator in your neighborhood or your town, because they've dug enough holes to be able to tell you what the profile is down to where your footing is. Soil surveys only go down 60 inches, 5 feet. And so there's a map of the entire United States broken down to like the multi-acre level, where you can go online and find out what the profile is from grade down 60 inches. But if you're digging a foundation, you got to know about double that. And the only way to double that is to talk to, some gnarly guy who's been digging holes a long time in your neighborhood. Jake, you have a story about that, right?
Yeah, we basically started to talk about a project with one of our excavators, and he literally said, "This is what we're going to find," because I dug that foundation and pointed to the left, and then I dug that foundation and I pointed to the right, and we were involved in cutting that road in 1973 when this road went in, and it exactly what you're saying. That guy with gray hair has more information than he gives up without you asking.
Yeah, really cool. So, Steve, you're right. You can, if you go at this at the design level, you can relieve a lot of the pressure that you might if you're going to ignore that.
Yeah, I mean, just I look at it as I try and get rid of the problem before it becomes a problem. Right? Take care of it at the building or away from the building before it gets to the building.
Which could be as simple as grading.
Yeah.
For a large part of what we're talking about, right?
Certainly. But this site was certainly exaggerated because of the steepness of the slope. But that steepness of the slope, there was probably a good half mile of upward slope that was above this house.
It's like the prow of a ship at that point, facing uphill.
It was crazy.
And Steve, when you put in that perforated pipe for that, did you put the perforations up or down?
That one was perforated all around. How about that?
Really?
And yeah, because we put probably like a 16-inch base of stone and then put the pipe in and then put stone above it. So it works as a French drain kind of. So it has the potential to store a little bit of water, but then get rid of it as it fills up to a higher level, if that makes sense.
I've never understood this. Holes are to allow water in. When in your perimeter drainage system do you move from wanting to let water in to conveying it away? Right?
Well, you're number one. Isn't the whole goal of that perimeter drain just to relieve pressure, so it doesn't matter if it moves away so long as it takes the pressure off.
Right.
Interesting.
Yeah. Don't think of it as a barrier. Think of it as a retarder.
Ooh.
Bulk water retarder.
Everybody loves a callback.
So Steve, when you use pipe that's only perforated on, half of the circumference, do you put it in
holes up?
Holes up.
Really?
So
yes.
Then you are trying to let water in when the water rises to the holes, it lets the water in, but then after it gets in, you're conveying it away. Correct?
Yes.
Interesting.
So I'm gonna play devil's advocate. I agree with Steve on this one, and there's one more reason that I agree than what we just covered. But we for the longest time I was a proponent of holes down, because that foundation drain tile is there to catch the water as quickly as possible and get it away. And that water that I'm trying to capture is most likely groundwater and not site water from above, because we're doing a really good job of managing site water with gutters and grading. And so I, for a long time, made the argument that we're putting it holes down because we want to capture it as quick as possible. And
sort of water coming up rather than water coming down. Yeah. Interesting.
And it's just there to pressure equalize.
Mm-hmm.
What do you have to say about that, Steve?
Yeah, I mean, I agree. It's like in my basement here, I have holes up, and I can go down almost any time, pop the cover of one of my 2 sump pits, and I see water down there. But water 10 inches below the bottom of my footing doesn't bother me, right? It's when it comes above the slab. That's when it bothers me. And I have an extremely high water table here. I tell people my house is like, our town is a bathroom sink and I live at the drain. Right? So we get all the water here.
So when you go to sell that house, I wouldn't use that catchy phrase if I were you.
No, I wouldn't. But I have.
This is
I actually,
where you enter the sewer.
You're gonna like this, Peter. I actually put 2 sump pumps in, but I didn't put 2 sump pumps in the same. I have one that I've deemed the primary. That sump pump pumps up into a pipe and goes into the sewer system. The second one is the pump is on a brick in the sump basin. So it's slightly higher, a couple inches higher, and it goes out of my house onto like a piece of slate, but would eventually drain to my driveway. So there have been times where I have driven up and seen water in my driveway and said, wow, imagine that. From my driveway, I can determine that my primary sump pump has failed.
You are awesome.
Huh?
Yeah.
You like that? I knew you'd like that.
Because I bet you if it pumps water out when the air temperature is below freezing, all the neighborhood kids come to skate your driveway.
Yeah.
So this holes up, holes down thing, the reason that we no longer put the holes facing down, if we're using a one-sided perforated pipe, which we don't, we do use the all around, was actually an argument that I had with Steve, and Steve convinced me to change my mind. This is just pat Steve on the back day here. You better soak it up.
I hope all the listeners are listening to this. Listen, I'm getting kudos from both of them.
Steve said,
and it's not even my birthday yet.
Steve said, if you're going to put the holes facing down, a more minor silting event eliminates the utility of your pipe than what eliminates the utility of my pipe. And so if the holes are facing up, that pipe could be 50 to 75% silted in and still actually do its job on some level. But holes facing down and we're 25% maybe, and those holes are covered where they're not doing their job. The moral of the story is actually don't argue about which way it goes. It's just buy pipe that's perforated all the way around, or drill holes in it, because we don't have any place in Columbia that stocks a holes all the way around. So we just set it in place, holes facing down. Then before we cover it up, we just go back and drill some holes in the
I mean, most of the guys, not only do you get a pipe with holes all around, but they'll buy it and it comes with a filter sock.
Mm-hmm.
So only water can move into the pipe.
So. I kind of want to join this love fest. I'm hoping you guys are going to like this.
As long as you don't call it a love fest anymore, you go right ahead.
Yeah.
I think we ought to be installing cleanouts that give you access so that not if it silts, but when it silts, you can clean it out just like you do a sewer line.
And the reason I just started laughing is because I was thinking ahead and thought the same thing, and then thought, shoot, we were like 2 days from backfilling a project and I haven't put in a clean out. I'm going
to play devil's advocate on this one. So this is where the love fest ends.
Uh-oh.
I know where you're going with this too.
So a couple years ago.
You and your aesthetics.
No, not at all. Okay. Not at all. A couple years ago, I got called in on a project, a good friend, builder of mine, and he builds exceptionally great houses. They're all multi-seven-figure homes, but he took on remodeling this one house for a couple. That they bought this house. It was a multi-million-dollar house, and it was only a couple years old, and they were already remodeling. But the homeowner had said, the basement, I think, was 16 foot deep, and there was a theater down in the basement.
Oh, boy.
And he's like, yeah, in rain events, I get tons of water in this corner. It's always wet. And the builder said, what do you think? And I said, I think nobody is going to like the answer I'm about to tell you. Because
option one is move.
Yeah, option one is move. And the fact that they just bought the house and moved in, they probably don't like that as an option. And so the option was to excavate the foundation along the whole back of the house, which was
16 feet deep.
16 feet deep. The excavation, and this builder, you can't just excavate 2 or 3 feet. It was probably 5 or 6 feet from the foundation. And the length of the hole or the trench was probably in the 100-foot plus range. And the disgusting thing was when we did get down there, it had a drain tile, it had filter fabric, and it had stone. Everything that's needed was there. When I cut through the perimeter drain, it was fully silted. And part of the hating your idea of cleanouts, Peter, is if I knew that was the problem, I don't know how you would have been able to snake this problem to a solution, because it was packed in there like cement. And it wasn't like clean outs. I understand you get a clog, you get a clean out, but you're solving for a problem that's probably 2 or 3 inches in length.
Mm-hmm.
That once I poke through, I get some water movement, I get some degradation. It's organic material, right? That a little water mix, it's gonna work in your favor. If I have 20 feet of perimeter pipe that is filled with silt and dirt and stuff, and I can't push water through it, I don't know how you snake that.
Yeah. So why was it silted that packed in?
So, like I said, everything was there, but it just wasn't installed properly.
Yeah.
Execution.
I mean, the execution, and we talk about this all the time. It's not the materials you use. It's, how did they get installed? This particular project, I could have done a better installation if I kicked the stones off the yard into the hole and then kicked the pipe and filter fabric into the hole and back covered it. Because that's exactly what they did. They literally, we need a pipe. They threw it in there. Oh, we need filter fabric. They laid it over the top and then they backfilled. And it was absolutely horrible execution. And the thing that really baffles me is this builder knew on the other side of this 12-inch concrete wall, he's building, home theater, home gym, all of these spaces. It's not like, if this leaks, the people's, their little storage area might get a little bit of water.
Their dirt floor might get a tiny bit.
Yeah, if this leaks, that $200,000 theater room on the other side of this wall is going to get ruined.
So you're not really against the idea of a clean out. It's just like that. Don't put your money there if you're not going to bother to do the rest right.
Yeah. I mean, a clean out might solve the problem. Like I guess here's my question or retort to you with the clean out concept. How do I identify the problem? Right. And at what point am I able to identify the problem? Because if I can identify blockage almost immediately,
right, then
you could drop something in and clean it out. But if I can't identify that problem for a year after the problem's been building, I'm not convinced you could snake that clean.
Yeah. Well, I guess if you had a drain to daylight, you'd have to go look and see if, when it rains hard, do you actually get
I mean, you might be able to put a hose or something on it and apply some high pressure water and push dirt along or something and clean it out that way.
Right.
But it's one of those things where I think the world underground is an area where you can make some assumptions, but those assumptions have to be reassessed before execution. Right. So, okay, I can assume we're going to put a 4-inch drain tile in. It's kind of like that house on the hillside. Okay, we're going to put a perimeter drain in. We're going to put a dimple mat in. Well, after I saw that water, we reassessed it and we added that stone trench with the 6-inch pipe to take care of it. So the same thing is if I dig a hole and there's standing water or I know there's a water issue, then maybe that 4-inch pipe becomes a 6-inch pipe. Right. And the stone that it's in is not 24 inches deep. It's 40 inches deep or something.
So you're gauging your response to the threat.
Yeah. Or it's not 1 sump pump. It's 2 sump pumps. So it gets back to, when Jake talked about control, that you need to have the knowledge to apply the level of control required for success.
This is interesting that we're focused on design because the other big issue is, what about existing, foundations and how you might change the way that they work after the fact? Because this is definitely an advertisement for don't put yourself in that position, right? Do it right the first time, because if you have to solve for a moisture problem after the fact, it is going to be painful and probably expensive.
Yeah, and
so
when you're dealing with
one opportunity.
Yeah, when you're dealing with underground, your first expense is access and exposure.
Right.
So you're digging a big ass hole in your house. Now, that you can imagine the $2 million or the multi-million-dollar house, right? That 100 feet of back elevation. It wasn't like there wasn't a patio there or, a small deck and landscaping. Right?
And
So
landscaping in the side yard to get to that point.
Yeah. So you're not talking about, hey, we're just going to dig a hole in the North 40. You're taking someone's very well manicured backyard and now digging it up.
And Steve, was this house of the age that the existing, everything was concrete? There was no rubble foundation or?
No. We did this. This project was probably about 8 years ago, and I want to say the house was built like 4 years before that. So the house is like 12 years old.
Wow.
But I see it all the time.
It doesn't take very long.
No, I see it all the time. I drive by projects, especially when they're excavating or putting in foundations, and they won't even put a drain tile in. They'll just put back the dirt that they had.
I'm working on a project right now in nearby southeastern New Hampshire, where a couple is trying to decide whether to buy a home, and there's moisture problems in the house, and we sort of went through this. Because they're trying to do this as much as they can themselves. And I said, well, probably I'm going to have to come to look at the project sooner or later. But I just went through with them the different loads. And it was really interesting because, we talked about water table and how they might assess that. Then we talked about site surface water management. And then we talked about the building load. And the interesting thing is that he said, well, we've got this white dust that's about 5 feet up from the basement floor. And I'm told that that's something we have to figure out too. So what was that? That was efflorescence. And so efflorescence only happens if you've got liquid water wicking up from below. And so we went through this discussion process, but they're totally tuned into, well, let's try to figure this out as much as we can ourselves by logically going through, well, where is it the building load that's the problem? Is it the site surface management, or is it water table? Because as you said, if it's a water table issue, the approach is going to be very, very different than if we can figure out how to redirect the building load or the surface load.
Yeah, it's just the underground is probably. It is the least sexiest of the building, right? I mean, there is nothing exciting about the foundation wall.
Attics are pretty bad too.
Yeah, they are. Peter likes attics, though. It baffles me. But yeah, it's the least sexiest. So it's like, we tend to want to make that very short conversation. Yeah. Put in whatever pipe you need. Yeah. Just put some stone in there. Yeah. Do that. And we don't really give it. I guess our thought process on stuff below grade is not nearly proportional to the amount of thought we put above grade on things. And it should.
And I think
be
what's
a
little unfortunate is that we get away with quite a bit, because if we're building the foundation out of concrete, it does have a lot of capacity to safely hold water. And that lulls us into thinking, well, maybe I don't have to be quite as anal about water management because I've got a system that doesn't care if it's wet and can hold an awful lot. And that gets us into trouble. I remember one of the first research projects when I was at the NHB Research Center back in 1993 that a buddy of mine was working on was the Superior Walls system, where they're manufactured panels. And we just thought, this is insane. They're doing no waterproofing or damp proofing on this concrete, and these panels are dropping into the ground. Well, the PSI rating on the concrete was 7,000 PSI. Well, it turns out...
I even thought it was higher. I thought it was more like 9.
Well, it's high. I'm pretty sure it's 7, but let's just say it's high enough.
7 plus, yeah.
It's high enough that the pores no longer support wicking or capillary movement. In other words, the concrete is dense enough that you don't have to worry about moisture moving through as a liquid. And that flabbergasted me. I just assumed if it's concrete, it's got to be porous. No, if you make it dense enough, you can eliminate the fact that the pores aren't talking to each other anymore. They're too small and they're too discontinuous.
All right. Speaking of construction, I have major construction going out in front of my house.
Nice to know that your road's getting paved today.
It's already paved. What they're doing now is they have a series of dump trucks with a grade all. So they're filling in kind of the spots along the sides and driveways and stuff with loam and prettying it all up and wrapping it up. But
they're trying to make sure that the load that comes down on the road ends up in your front yard.
And I apologize, but I have absolutely no control of this. It's literally right outside my window.
I hear this beeping all the time. I thought
lack of control.
Yeah. But I actually had a really good point that I now lost.
That's okay.
Oh, no. I do have it. So I think what else? Two things. One, the superior walls. We use those on a demonstration project up in Flint, Michigan at Building Science Corporation. So that's when I got to work with them. And what was interesting was they didn't use that high strength concrete because it made it more waterproof. They used it because the higher strength concrete allowed them to be able to strip the forms and move the panels quicker.
No kidding. So when they're casting them at their manufacturing facility, it was a production issue, not a performance issue.
Exactly.
Holy smokes, that is fascinating.
The performance was a byproduct of it.
A bonus.
The strength of concrete was all about production speed and ability to.
That is really. I had no idea. That is really cool.
I wow you daily. I'm feeling really good about myself. All these wows I'm getting from
just
Peter Yost.
Wait for it. There's plenty of time to turn it around.
Thanks, Downer Jake.
Okay, so we've talked about drain tile now, and assuming that we're talking about crawl space or a basement below grade foundations still, where we start to travel from the footing upwards, what is our next control layer? What is it in your mind? What's the next control layer? Like what item are we using for that moisture control, I guess is what I'm trying to say.
I think I mean, like anything, it depends, right? It depends on if I look at the excavation hole and I see the seasonal high water table at 4 foot below grade, so I know the bottom 3 feet of that foundation wall is going to get challenged for part of the year, then maybe waterproofing as opposed to a damp proofing or, tar on the foundation. But I have some projects also that are, one of them is in literally 20 feet of compressed beach sand. You could pour water anywhere on this site and it immediately disappears. And that's on top of the hole, around the perimeter of the hole, in the bottom center of the hole. You could let a hose run and it just disappears.
So can I jump in real quick and say that
Peter, I would love to hear what you have to say.
the technical difference between damp proofing and waterproofing is waterproofing is per the ASTM standard. It resists a column of water. I think it's at least 8 feet tall. And then secondly, it's got to be able to bridge a crack of like 1/4 of an inch, right? So literally the waterproofing is designed for hydrostatic pressure and it is designed to withstand hairline cracks in the concrete, whereas damp proofing does not. So it costs more, the waterproofing, but it is a higher performance material.
And what are we talking about when we talk about cost? Are we talking about just first cost, or are we talking about we're back 3 years later to dig it up and install waterproofing because all we did was damp proofing? Because it's certainly cheaper to install it the first time than it is to install it the second time.
I think since you get one chance to do this almost all the time, you would just go with the extra insurance or the extra cost. But I find Steve's tuning of his water management to the threat compelling.
Well, and there's budget constraint there too, I'm sure.
Yeah.
Not every
and
house
guess
gets
where-
the absolute best of everything.
Here's a question for you, Peter. Guess where homeowners' number one financial desire to spend money is?
Countertops?
No, basement waterproofing.
Oh.
I mean, every one of my clients say, Steve, just spend as much as you need there.
Huh. I thought you were gonna say they don't want to spend anything below grade because who gives a crap about how their basement
I'm
looks?
being sarcastic.
Okay.
Yeah, that's exactly right. People, you say waterproofing, and then the builder says, yeah, we could do waterproofing for this amount, but
tar.
for like 30% of that, we can just put the tar on that I put on. And I built that house down the street and we put tar on that and they never had a
12
problem.
years old, yeah.
But here's another big difference. This is probably more true of my area than say Jake's area, is when you living this close to the city, properties are expensive.
Yeah.
And you can't go buy 5 acres at will where I am, unless you're one of 50 people.
Not unless you make my
Boston
kind of money.
Unless you make Jake's kind of money. So with that, people are always looking for ways to expand what they do. And, one of the most likely places is let's push that into the basement. Let's put a gym down there. Let's put this down there.
Yeah.
And so, like everything that we talk about lately, is we concentrate on how do we solve these problems, but the expectations from our clients are a lot higher now than they've ever been. Because, we'll go back to the house I grew up in. If water came through the wall, and I said, hey, Dad, you got water coming through the wall. He's like, yeah, idiot, it rained last night. That's what happens.
Right.
Right?
A river runs through it.
Yeah. But now, when people have their $200,000 home theater down there, yeah, water coming through the wall is not quite the option that it might have been many moons ago.
Yeah, I just want to throw in here that when we're talking about existing foundation systems, when I do trainings with remodelers, I get this question all the time. Can I waterproof the inside after the fact?
Yes.
Yeah. And
I have a system for that. I wrote an article in Fine Home Building years ago.
And was that to do a interior French drain and work into that?
So we actually, in that case, you could have done, we would have just done a perimeter drain, but we removed the whole slab because the homeowner wanted a slightly deeper basement. But when we poured the new slab, there's a company, I can't remember their name because I would have plugged them, but they made this L-shaped corrugated piece of plastic, which was basically a pour stop. So
I think it's Formadrain.
It's something like that. If it isn't
Okay.
them specifically, but it is something like that. And so the bottom leg of it was tied to the stone pad, and then it came up out of it, and you poured the concrete up to it. But after the concrete was cured, this particular house was 1850s, so it was that stone. Yeah, I get rid of the trucks, and now my dogs decide to go in concert down there. And the puppy gets the other one all riled up, and they won't shut up. And there's nothing I can do. They're as far away as I can get them.
Can't you put them in your basement?
Do you know what my basement would look like? Goose, that's like chew toy heaven for him down there. But anyways, so you poured that pour stop. So you have this vertical leg that's stuck out of the slab about 2 inches. And then this was all done by the same waterproofing guy. There was this kind of cross laminated poly that he nailed to the mud sill, and then basically tucked it in behind that corrugation. So you basically, it's a it's a fancy way of saying we put a shower curtain on the inside of it, and we tucked the shower curtain in behind this flange that directed the water under the slab into the stone, into the sump pump.
So if you can't stop the water from coming in, just provide a place for it to go to, a path.
Yes.
Without anything being damaged.
But even then, I have a story about failed knowledge. Right? So I have a lot of stories about water. Why? Because it's the number one problem of buildings, right? I mean, over 75% of what we all see as a problem probably has water in it. But you always tend to remember the ones that might not have been the brightest of solutions. But I got called a small town west of Boston here. I got called in and the guy says, hey, we have this water problem, a builder. It's like, can you come out and help us? So these people live like on the bottom of a hill that's basically all ledge. And they had water problems in their basement. Okay. Do you know what their solution was? To dig a hole about 40 feet away from the basement, put in a water tank, French drain percolation tank.
Like a dry well?
Yeah, exactly. Yeah, dry well. I was at a loss for it. But this was a precast manufactured one, right? So they put that in, they put it a stone base, they set it, and then they filled it up with stone, and then they put loam over it, and it had a little manhole cover. When I came to the site, it just so happened to be a rainy day. Guess what was happening? Water was coming out of the manhole cover. It's like, what makes you think that the problem you had over here would get solved by pumping the water 40 feet in that direction? Isn't it pretty safe to say that the water conditions over there, or the below grade conditions, are the same? So the water you're pumping over there is you're filling up a tank that's already filled up by the water coming down this granite ledge hill.
Watch this hand.
Yeah. And these people probably spent like 10, 15 grand on putting that in, cutting the driveway, putting the pumps and the drains and all this stuff in. But it's like people, when it comes to foundations, I guess the moral of this story is people are only concerned with like, what's the immediate 5 foot area around the foundation? Because something else is happening 10 feet away. Right. Just because the water table's 3 feet here, it's probably 12 feet down over there.
Well, Steve, where I was going was, short of really managing it, can I Band-Aid it by putting some sort of coating on the inside of the concrete wall because I failed to put, or didn't have the opportunity to put something on the outside? That negative side waterproofing.
That sounds like a wingnut test.
Oh, thank you, Steve. Yeah, so we probably don't have time to go into great detail, but yes, there are certain compounds you can use called crystalline negative side waterproofing, but it comes with a lot of caveats, and I did a bunch of testing on these materials to try to figure out if you can actually manage that load with a after the fact coating. So if you go to,
and where can I find more information about that?
So if you go to greenbuildingadvisor.com and you type in wingnut negative side waterproofing, you're going to find out way more than you ever wanted to about how to coat basements from the inside, or if you really should.
But you know what I find really interesting about your wingnut testing? It is like polar emotional. Yeah, I know. Put the hat on. It is polar emotional extremes happening at the same moment in time, right?
What do you mean by that?
You do this test and you realize like you've reimagined Einstein's theory of relativity.
Really?
But then you look around and you realize you're in your basement in Brattleboro by yourself and it's 11 o'clock at night. And you have nobody to share it with.
No one's going to listen to you. You go upstairs to tell your wife and she goes, shh, I'm watching.
Oh, yeah, I'm watching.
Those are my stories.
The lights are on, but nobody's home. I get that a lot.
So it's like you get this like huge amped because you've figured this out, but then there's absolutely nobody there to share it with.
Yeah, well,
If Peter conducts an experiment in the woods,
right. Does
I will
anybody,
give you
does
this.
anybody hear the tree fall?
And this is just because our listeners out there know I believe in the buddy system. So I'm going to throw Buddy out there at you. The next time you're in your basement and you reimagine one of Einstein's theories, you feel free to call me on my cell phone and I will answer and I will listen very intently to everything you have to tell me and be excited for you.
Yeah.
Because that's the kind of guy I am.
Well, the problem is, I'm never going to call after 9 p.m. because I'm no longer a wingnut after about 9 p.m. East Coast time.
Okay, so we're kind of coming towards an end here yet, and we haven't talked about. We've talked about draining the water away. We've talked about managing the water before it gets there. We've talked about waterproofing the foundation with a coating, but we haven't talked about relieving the pressure on the vertical surface of the foundation. We haven't talked about a dimple mat or a drainage plane.
I think we talked about everything that is right up to, okay, how do we do it?
Yeah.
Which is a good break.
And are we going to call it here, or are we going to make this a 2-part series, or are we going to explain
I think we
now?
come back because there's way too much to talk about.
Okay.
I have endless stories about underground.
Oh, this is like designing in a cliffhanger. You guys are brilliant.
Oh, yeah.
So pause all of your projects that have foundations. Don't backfill until we publish the next episode of the Unbuild It podcast, Goes Underground. Do you guys have any parting words before I give my spiel about how to get in touch with us?
No, you spiel away.
I love going underground with you guys.
Okay.
It pulls me up.
Just so we're clear, if I had to pick post-apocalypse bunker buddies, I'm no offense.
Our spouses would
not
say,
sure.
You 3 guys, you go in the hole.
You know when they say, like, suicide is never an option?
Yes, it is.
In some instances, I don't.
We're not making light of mental health before we get any notes. We're just joking around amongst friends.
Yes.
So, just so you guys know, you can reach us questions at unbuilditpodcast.com. You can ask us questions or just give us nice compliments on Instagram, the Unbuild It Podcast. You can also catch all 3 of us on Instagram. Steve is Steven Basic Architect on Instagram. I'm Jake.Bruton on Instagram. And Peter probably has an Instagram too. And I'm going to see if he can remember what his own Instagram is, because this is my favorite part of every episode.
Wait a minute, what's Instagram again?
Okay, there we go. So you can just look for him.
Hey, Jake, I'm gonna plug Alex's and tell people to follow also Alexandra Basic on Instagram, because my daughter just recently came to work for me, so it's pretty safe to say that what she does, I do, and what I'm doing, she's doing.
What is her official job title, by the way?
Her official project architect. How's that?
Okay.
She graduated and went right.
Well, and the very first thing you should do when you contact Lexi is to say my condolences, because she's got to work with him full time. We just do.
Listen, there's already people on IG that like trying to side with her and give me crap. So
I could see that.
I don't understand it.
We would also like to announce that the Unbuild It podcast is giving away a Christmas present this year to one of our listeners. A
holiday present.
A holiday present. It's already up on the IG by the time this publishes, but we are going to be giving away a Yeti cooler and a bunch of sponsor swag inside that cooler. So you have to go to our IG account, you have to subscribe, you have to comment, you have to follow the other rules of the contest. But we want to be able to give this cooler away in time for you to use it for Christmas, because who doesn't need a cooler full of beer to get through the holiday season, no matter what your holiday is.
Well, let me just point out, Jake, that the cooler manages the energy flow And the beverages in there are all about managing moisture flow.
There you go. Nerdville it is. This is where we live, people. This is where we exist. And unfortunately, sometimes we shake our heads when Peter talks, and sometimes we laugh and agree. And Steve's nodding and shaking his head.
Because you put that vision in. Imagine if the three of us were locked in a 12 by 12 bunker. There's no place to get away. I wouldn't have fingernails. I'd be scratching at the wall trying to dig my way out.
This is the longest outro in the history of our show, too, by the way. Okay, so part 1, Unbuild It podcast goes underground. Stay tuned. In a few weeks' time, you'll be able to listen to the UBIB crew underground again. And hopefully no more references about being locked in a bunker during post-apocalypse Christmas. Thank you, gentlemen.
Thanks, you guys.
All right, gents.